Very soothing. Okay, here we go. Separation of vehicles, maybe. Here's what we have to do, okay? And I want to get through this as quickly as possible because I want you to start your homework before you leave today. Can I get an amen? Okay, so y prime. Folks, this notation kind of flips me out a little bit. So I have to go not to the y prime, but I need to rewrite this how. dy dx. And I was like, why is this a big deal for me? But this is, remember the Leibniz and the other guy who discovered this calculus thing at the same time? Yeah. This is Leibniz notation, not that y'all care. That's his name. But that's what I tend to prefer, so that's why I'm using the dy dx. Anyway, separating the variables. It is exactly what it says, separation of variables. What do you think that means? Pulling them apart. I want to separate the x's from the y's, okay? Doesn't sound very nice when you say it that way. But how am I going to separate the variables on this problem? I'm going to cross multiply, right? That's an algebra skill. That's not a calculus skill, folks. So here we go. Y times dy, y'all cool with that, is equal to what? You tell me. 2x dx. I am solving a differential equation. Today and tomorrow, I think, will be very easy for y'all. Now, what do you think I do from here on out? Say what? No, I'm not done. How am I going to solve it? I'm going to integrate both sides. Because what I do to one side, I'm going to interrogate them. I so am going to interrogate both sides. How do you integrate y dy? Is it y squared over 2? Hey, what am I going to do with integrating 2x? We would bring the 2 out, and the x would be x squared over 2, correct? Plus 2. Why? Because it's an indefinite integral, yes? Just at the end, and I'll explain that why in just a second. Technically, it needs to be both sides. However, I'll address that in just a second. I've got to clean this up. Y squared over 2 is equal to x squared plus c. Technically, I need a c on both sides. However, they work themselves out. And what does c represent? A number, any constant. So if I have 2 of them, don't I have just twice that constant? So I just put it on one side because it's all going to work itself out in the end, okay? Now, the thing about these differential equations, I have to have constants as my coefficients, no fractions. So I've got to eliminate the 2 in the denominator. Again, algebra. How am I going to eliminate the 2 in the denominator? Multiply what? The whole thing or both sides by what number? 2. Let's do that. Or 2 over 1, because when I multiply every single thing in that equation by 2, my 2's cancel here for this denominator, and that leaves me with y squared is equal to what? 2x squared. Do I have to put 2c? No, because it's twice some constant. That's not going to change. I want to set this equal to c, folks. So what am I going to do? I just want to set it equal to c. I'm going to take 2x squared away from both sides. And it's going to leave me with y squared minus 2x squared equals c. This is the general solution 2, what was our original problem?
Disregard the bell, please disregard the bell.
You do not have to write that every time, folks. Put the right side over 1. Why? So I can cross multiply. What's it going to give me, folks? One times dy is dy. Somebody else, what do I do now, folks? Not yet. I got to integrate. Once I integrate, that's when I add c. Okay? Integrate what? Both sides. What are you seeing? The left side's easy, right? Because I'm actually integrating 1 to get y. What about 6 minus x? And I shouldn't have put it in parentheses. Can I integrate each piece? I know y'all love when I do this. You're welcome. I don't need that negative x, though. I need to be positive x. What do I get when I integrate 6 dx? Over 1, which I don't really need that there. What do you get when you integrate x? X squared over 2? Keenel, what now? That a girl. Are we cool? What now? All right, what do I have to eliminate? I got to get rid of the fraction. So what do I do? Multiply it by 2. I do not want a fraction. What's that going to give me, folks? Plus c. It's no sense in multiplying c by 2 because it's a sum constant anyway. To get rid of the fraction. Solve this for c. Yes. Solve it for c. Because the book has something different. Oh, fart. Brain break. Okay. Okay. 2 things, and that's why I was checking. I had an answer. I had a question to Ms. Callie about this earlier. Guys, please listen. When you're checking your answers, some of your answers in the back of the book are going to be set equal to C, and some will be set equal to Y. The letter Y, not the question Y, okay? So, that being said, if we had this set equal to Y, then, well, let's solve this. Finish solving this for C. What do I need to do? Just move everything to the left and it'll be equal to C, correct? All right, so I have 2y minus 12x plus x squared equals C. Is that acceptable? How many of you had that? Okay, that is an acceptable solution. Ms. Kelly just said in the email, that's what I wanted to check, In most cases, we need to set this equal to y, the letter y. And if that's the case, then we had the answer right here. Y equals 6x minus x squared over 2 plus c. And that's what the book had as its solution. And she said there is no rhyme or reason why sometimes they solve for c, sometimes they solve for y, but if you solve for either of the two, I ought to be able to find your answer easily, okay? Most cases, I'm going to tell you solve for C, the general solution. Solve for Y, okay? Question, you'll just see. This is a star-worthy problem. Means something's going to be strange, okay? What do we need to do? What do I do? Same thing we did before, and cross multiply, correct? All right. dy equals. Did that help us? No. What now? Divide by the quantity, y plus 3. This is where it gets a little weird. They cancel out on the right. And y'all know that drives me insane, that left side. Well, how am I going to separate it? 1 over y plus 3, dy is equal to dx. Why does that drive me crazy? Because it's a fraction, but y'all know, of all of my students ever who have ever known this, you guys probably know better than anybody, I am so visual, I need to see it match the rule, right? I need to see 1 over u du. Are you with me? Okay, I need to see that. At this point, do I have all my x's together? Do I have all my y's together? What do I do now? I integrate. And then what's going to happen when I integrate this? Is this going to be some easy little integration problem? It's not a difficult problem, but there's a little twist to it, right? What do I have to use? Use substitution, which takes me to natural log. Okay? So, integrate both sides. I got to talk about my u's. What would my u be on that left side? You guys see that? Do you agree? And this one really, for the u substitution, it's really easy, isn't it? Do I even, what's it going to be? Du over dy is going to be what? 1. That means du is 1 dy. Does it all work out for me nicely? When I integrate 1 over y plus 3, folks, what do I get? Are you down with that? Does that look familiar to you, yes or no? Yeah, would you be able to do that on your own? You better. All right. I always throw it on the right side. I don't know why. Integrate the right side. What do you get? Just x plus c. Is everybody with me so far? Yes, no, or maybe? Or definitely Everybody good? What now? Now, how you going to solve that? Look at it, would you? What? This is the point where you go, what has she done? And why is she doing this to us? Okay? What the crap? Here's the what the crap piece. I've got to solve it for C or for what variable? Y. Either one of those. I cannot have that natural log thing in there with that absolute value. So how do I get rid of a natural log? Introduce e to both sides of the equation. And what I do to one side, it's e to the this power, all of this stuff right here, becomes the power of E. And then E to the x plus C. This is the weird part. This is the only way I can solve this. The only way I know. And it's the way the book's going to show you too. Now, folks, when you have E raised to a power, E to the ln of something, it's the something. So it's just the y plus 3. We lose the absolute value symbols. And then we still have this ugly E to the x plus C power. Right? I'm glad I'm recording this. Solve for y. Subtract 3 and I get y is equal to E to the x plus C minus 3. Do you guys agree with that? Am I done? What? How do we get the C? Okay, here's how you take care of this. There is a problem that you guys have to be prepared for, okay? We have to use our E and ln property. The green sheet, you really got to have that out with all of the next few days, okay? The way I'm going to address the E to the x plus C, because I can't have the C up there in the power, I'm going to do this. When I have a power that is added, what does it actually mean? Do you remember your properties? I'm going to multiply. So here's what I have to do. It's going to be E to the x times E to the C minus 3. All I'm doing is I'm applying my natural log, my exponential rules. And then, and this is straight off your green sheet, whenever I have E to a constant, the constant goes to the front and the E drops away. This becomes that right there. It's one of the rules. It's on your green sheet. Where's my green sheet? Right here. And this is just applications of the same thing we just that we're doing. Folks, here's what it's going to say. It's going to say the rate of change of y is proportional to y. What are you doing? You've lost your mind. You're back. Well, how's it going to dy dx? Is, hello, is an equal sign. Proportional to y. Hey, this should look familiar to you. Does that look familiar? Okay. ky. This is direct variation from Algebra 2. Anytime you see dy dx ky or y prime equals ky, you're going to use Theorem 6.1, which is in your book, and it is a same formula every time. Y equals C E K T, not RT. C being the constant, E is our favorite letter number, E, to the KT power, okay? Now, just FYI, I'm going to smack you. Write it down. Okay, good. Stop talking. Yep. C is the initial value. K is the what? Constant of proportionality. Is that good? I'm going to bet it. When K is greater than 0, you're going to have exponential growth. And when K is less than 0, you're going to have exponential decay. And this is real life stuff. Somebody somewhere uses this. Constant of proportionality, which was that was on your last FRQ, wasn't it? Remember you had to solve for K? So here it is again. You need to make a note on your paper that you need to look at page 398, example 2. Page 398, example 2. Look, ponder, think, etc. I want you to look at that problem when you get a chance, because I know how you enjoy reading about math. Do you need to stand up? Go to Theorem 6.1 because of this right here. The rate of change of n is proportional to n. This is what allows us to set it up as n equals CE to the KT. And I don't know about you, but when it's not X's and Y's, that kind of messes with me. Think of T as your X value and think of capital N as your Y value. I just need to know that for me, okay? Now, the first ordered pair, if you will, that we're given is this 0 to 50. Do you guys agree with that? So I'm going to put it into an ordered pair format just for me. This is T and this is N. And I'm going to plug all of those values into my 6.1 formula. I don't know what to call this. The exponential. Okay? So, here we go. Okay, I'm recording. N is 250. C, I don't know. E is really just what? 2.7 something, right? It's a number. K, I don't know. But T is 0. What's going to happen there? I'm going to have 250 equals C times e to the 0 power. And what is anything to the 0 power? 1. That turns into 1. You do not have to put this. But 250 is C, is it not? Okay. Now, that's good. I took care of this first piece right here. Now what do? Take care of the second piece of information. Y'all said it just looks like a bunch of information. I agree. It does. So same formula. And this time we're going to use what? The other information, right? 1/400. All right, so what is N, folks? Do I know what C is? Yes, I just saw for it. This is the part that it kind of keeps filtering over into the next problem. E to the K times 1, right? You divide by 250, which is right. Not yet. What do I have? 400 divided by 250 is 8/5, isn't it? And now what? Not yet. LN both sides. Why? When I take the natural log of both sides, folks, that's the inverse of exponential, okay? So I'm doing the same thing I would do. Take the natural log of both sides. And folks, right here, use your natural log rules. When we take the natural log of e to the k, what does that give us? K. Not like okay, but the letter K. Now we have our K value. Yes? Are we done? No, not yet. There's more. Calm down. Now we're going to plug everything back into the same formula again. Isn't this fun stuff? This is so much fun. I just have to, no, I'm not laughing at you. I'm sorry. I am. T is 4. Are we going to use this bit of information? Find the value of n when T is 4. One more time. Here we go. N is what we're finding. C is what? 250. This is going to look so beautiful. E to the who? Times 4. Because it was our information, that last piece of information. Wow. Isn't it? And on an AP exam, what would you do? If this were an FR, you would not freak out. Freaking out is not an option. If this were an FRQ, you would leave your answer like this, right? If this were multiple choice, this is what we would do. We got to clean that up, that power part. I'm going to put the 4 at the front of the LN, just to make it look nice. And I might turn around and chase my tail here in just a second. If I do, I will. No, we ain't done. No, honey, we ain't done. We ain't done. What is E to that power equal to? That stuff, that power. This right here. This right here, we're going to use our rule again. E to the something is that something. Bless you. And then you said 8/5 to the 4th power, which is absolutely right. The rule here and here. It's one of the rules for natural logs with the exponential. Okay? And that's why I'm telling you, you got to have that green sheet, that laminated sheet with you at all times this week. This right here, if we didn't have a calculator, wouldn't we leave our answer this way? I'm not going to calculate that out. It's not necessary to. But now we're done. Pardon? Could I? Yeah, you could too. Just 8 times 8 times 8 times 8 over 5 times 5 times 5 times 5. I would figure out what that is and multiply it by 250. You would do that too. I don't want to. That's why I left my answer that way. Okay? See what? Oh, okay. Did I pass? Yes. Okay. Questions? Yes, sir. I didn't see you because you're laying in the floor. I'm sorry. I didn't hear that.